Hey guys, welcome back to AP Pre-Calc. This is lesson 1.6 and behavior. Let's get right into it. So here's the bell ringer for today. Pause the video if you haven't done this already because I'm about to go over the answer. So we are given a table of values for a polynomial function. Which of the following statements about g could be true? And so we want to see first, is it an odd or an even function? And then looking at the answer choices, we want to see what is g of -1. All right, so to see if it's an odd or even function, let's review our rules for odd and even coordinates. So for an odd coordinate, we know if we have x comma y as a point, we know -x comma -y will also be a point. And the same for even functions, right? If we have x comma y, we know -x comma y, so remember the y value doesn't change, would also be a point for even functions. So let's see if we can kind of match up some of these. So I see those two and I see those two as 2 points that may help us. So we have -4 comma 7 and 4 comma -7. And then we have -2 comma 3 and 2 comma -3. And so here we see that we're taking the opposite of both our x and our y value, which is going to be an example of an odd rule that we have. And so this is probably going to be an odd function. It definitely wouldn't be an even function. And so we can eliminate C and D. Now we want to find g of -1. So here, if we know we have the coordinates 1 comma -6, we also should have the coordinates -1 comma +6, right? Take the opposite of both your x and y value. This then should mean g of -1 should equal +6, so B is going to be our correct answer there. Now today we're going to be talking about end behavior. So the end behavior of a function describes how a function behaves as it moves to the right or to the left. So for example here, if we move to the right forever, we are going to be going up, right? This function will be constantly increasing. If we move to the left forever, our function is going to be going down. It's going to be shooting down and decreasing. So let's take a look at how we can word this. We can use limits or we can express it verbally. However, typically you're going to want to answer in terms of limits. I would stay away from the verbal responses. So here, the left tail end behavior is going to be the limit as x approaches infinity of just, let's say, f of x, right? So let's say we have this function again as x, which remember this is your x, approaches in negative infinity. That is as it goes in this direction right here. We say as the x values decrease without bound, meaning forever, the y values of x, and in this case, if this was true, we would say decrease without bounds. Now, let's take a look at the right tail end behavior. This is as the limit as x goes to positive infinity. As we would say here, as the x values increase without bounds, or as they go up forever, the y values of f of x, for like this function that I just drew, would also increase without bound. And that is what we would say for these limits here. So what is limit notation? Because we will have questions in the AP exam for sure that ask for an answer in the form of limit notation. And so there should be 4 parts to this. You need to include all 4 parts. If you don't include all 4 parts, it would be incorrect and would be given no credit on the AP exam, so that's pretty important. The first part is your limit, so writing the word LIM, and then you're looking at your x value, so put it under your limit as x approaches infinity. That's your first part. Your next part is going to be your function. So whatever function you're talking about could be f, g, h, k of x even. And it will specifically ask for what function they're talking about in the question is equal to, so that equal sign. And then, so that's your third part. And then your fourth part is your answer. What does that equal to? Maybe it might be positive infinity. It could be negative infinity, right? It really just depends on the actual function itself, and we'll learn how to find that today. This is just an example function, but this is how your limit should be structured. All right, so for example 1, describe the end behavior of the following polynomials using limit notation. Assume both functions are f of x when we're writing our limits. All right, so for the first one, we want to find our left behavior, which is as x decreases forever, our y value is going to increase. So let's write this, the limit as x approaches, and as we go to the left, this is always going to be negative infinity of f of x equals, and this goes up forever, so this should be positive infinity. Here, as x goes to the right forever, as it increases, our y values go down. So our limit as x approaches positive infinity of f of x should equal negative infinity. Let's take a look at this one. As x decreases forever, this function goes up. So I would write this as the limit as x approaches negative infinity of f of x equals positive infinity. And as our x values increase forever, this should be going up as well. So this would be the limit as x approaches positive infinity of f of x equals positive infinity. And those are what our limit statements should look like here. Let's take a look at polynomial end behavior. So polynomial end behavior really comes down to two things. You have to ask yourself this question about the leading term. So remember, you want to look at the leading term to answer this question. You want to see, is the leading coefficient, so is the leading coefficient positive or negative? And then you want to see, is the degree even or odd? And we kind of talked about even degree polynomials and behavior and how they go up or go down together. And so this is kind of where we answer that question, because that's going to impact our polynomial. You want to take your two answers. So there's four options, right? Either your leading coefficient is positive or your leading coefficient is negative. And then your degree is even or your degree is odd. And those are your four options. And match it up with one of the four basic functions for all four of these scenarios. Either x to the first, y equals negative x to the first, x squared, or negative x squared. So if your leading coefficient is positive and your degree is even, that should be x squared. If your leading coefficient is positive and your degree is odd, that's x to the first, or y equals x. If it's negative and it's even, y equals negative x squared. And if it's negative and odd, this is going to be just negative x. So let's take a look at all four graphs, and whatever graph the answers match up with will have the same end behavior. So these are the two basic graphs of y equals x and y equals negative x. So remember, these are both odd degrees, but this is a positive leading coefficient and then a negative leading coefficient. So here we see as x goes to negative infinity, this goes down. As x goes to positive infinity, this goes up. Likewise, negative infinity, this goes up. As x goes to the right, this goes down. And then we have y equals x squared and y equals negative x squared. So here, as x goes to the left or the right, they both go in the same direction. That's even degree end behavior. Or if it goes to the left or the right, they both go in the same direction, but with a negative leading coefficient, it goes down. With a positive leading coefficient, it goes up. I wouldn't even try to memorize each particular set of rules. I would just memorize the four basic graphs, and you should have these memorized already. And now you know what graph to match it up with, and then just draw the general graph like I do. If we have x to the fourth plus 3x squared minus 1, I take a look at x to the fourth. I draw out just like that quick graph of x squared, and then I know this whole polynomial function, as we go to the left or the right, my y values will both be increasing regardless. All right, so example number 2, determine the end behavior of the following polynomials using limit notation. So this function here is going to be a positive leading coefficient and an odd degree. So what function does this match up with? This should match up with y equals x to the first, which looks like this, which means our left-hand limit statement would be the limit as x approaches negative infinity for our left hand of f of x equals, and this goes down forever, so negative infinity. Our right-hand limit statement would be the limit as x approaches positive infinity of this is f of x equals positive infinity. Let's take a look at B. This one's a little tricky because our leading coefficient is not going to be positive. It's actually going to be negative here. And then our degree should be not even, but odd. Remember, your leading term is going to be your highest power. So it may not always be a range from highest to lowest. So really be careful with that because that could be tricky sometimes. Here, our left-hand limit statement should be the limit as x approaches negative infinity of, in this case, it's g of x. So you actually would get a question wrong if you write the wrong function, even if your limit statement's correct. So really be careful of that. And then this is going to match up with y equals negative x, so this graph right here. So as it goes to the left forever, our y values are going to go up, and then our limit as x approaches positive infinity of g of x is going to go down, so negative infinity there. All right, this one should be, our leading term should be positive, or leading coefficient should be positive, and then our degree should be odd, and so this is going to be y equals x again right there. So our left-hand limit is the limit as x approaches negative infinity of, in this case, h of x equals negative infinity, and then our limit as x approaches positive infinity of h of x equals positive infinity. And so that should be our answer there. Okay, so now we have example 3. 3 more examples, so let's take a look at these. We have negative 2x to the fifth. This is going to behave like y equals negative x, so like this. So our left-hand limit statement should be the limit as x approaches negative infinity of f of x equals, and this goes to positive infinity, and then the limit as x approaches positive infinity for our right-hand limit statement of f of x goes to negative infinity. This one here, this would be our leading term, so we should have a negative leading coefficient and an even degree. So this should be like that. Because we have this, our two limit statements would be as x approaches negative infinity of g of x equals negative infinity, and then the same as x approaches positive infinity, which should be negative infinity there. And now we have h of x, and so this is the limit as x approaches negative infinity of h of x, and I'm just going to set these up. I just like doing this, personal preference, but it's honestly up to you what order you do it. And now I'll take a look at the limits now that I have the limit statement set up. And so here we have a negative leading coefficient and an even degree. This will also be like y equals negative x squared. So this should be, as x goes to negative infinity, this should be going down to negative infinity, and this should also be negative infinity as well. So that would be all 3 of those limit statements. If you have any questions, please come see me during office hours, and I will see you guys later. Peace.